Good morning, children. In the previous class, we discussed Newton's first law and second law. In this class, we are going to discuss about the Newton's third law of motion. According to Newton's third law of motion, for every action, there is an equal and opposite reaction is there. That means when an object exerts a force on the other object, the second object also exerts a force on the first one, which is equal in magnitude but opposite in direction. For example, here I am going to apply some force on the wall, and the first object I am going to apply some force on wall. At the same time, the wall also exerts some force on me, which is in equal in magnitude but opposite in direction. That means I am pushing in this way, forward direction. The wall is exerting the force on the backward, that means opposite to the forward direction. That two forces which are exerted on each other is nothing but action and reaction pace. For example, we can take two marbles of A and B of different masses. Of course, if A exerts some force on B exerts force on A. The force exerted by A on B is called FAB. Children, you understand? The force exerted by A on B is called FAB. And the force exerted on A by B is called FBA. Both are equal but which are in opposite direction. Here the negative sign indicates that the direction, that means the acting of directions. That means the force, first force acting on the second force, second object exerts force on the first one, which are in opposite direction. So we have to say that FAB is equals to minus FBA. Children, while we discussed the first law and second law, that first and second law is only applied to a single body. But the third law applies to interaction between two bodies. Interaction between two bodies. Here, we are going to discuss some of the examples for the Newton's third law. First one is flying of birds. Children, do you know, while the birds are flying with wings, the birds will push the air downwards. With the wings, they will push the air downwards. The air pushes the bird upwards. That means pushing of air with the wings in the downwards is the action, and for that reaction is the air pushes the bird upwards. So this is the example for the flying of birds. And coming to the second one, swimming of fish. Children, you know that fishes can swim in the water. During this, they can push the water backwards. That is the action. And the water pushes the fish forward. So, the pushing of water by the fish is action, and the pushing of water, the fish into forward direction is reaction. Both are equal in magnitude but which are in opposite direction. That makes that swim to move in that water. And coming to that rocket. Children, you know that a rocket contains so many chambers. In the last chamber, fuel chamber, some chemicals are there. Those chemicals will be burning with air and expel a lot of gases. Because of that reaction between the fuel and oxygen, it releases some of them, expels the fumes, flame, that expelling of that gas comes down, so which is action, with the same effect, the rocket is moving in the upwards. That means whenever the expelling of gases comes downward direction, those will make the rocket to move in the upward direction. So rocket is also, working of rocket is also based upon the Newton's third law of motion. And coming to the walking, while you are observing, when we are walking, we can push our, that means we can push the floor with our leg. That is the action. To counterbalance that, the floor also pushes the leg forward. In this way, we are going to be walking. And coming to the balloon rackets. Children, you are playing with balloons. While we can feel the balloon with air, it is inflated. Inflated means bulges. While we observe these balloons and we can tie with a thread, while we observe the air present in the balloon exerts pressure in all the directions. Okay, children. Now we can tie with this a bamboo stick, small bamboo stick or a stick. Now we can release the air, means what happening? The air present in the balloon will be exerted in all the direction, but there is only chance for coming the air from this nozzle. Whenever the air is coming, that is the action. That air makes the balloon to move in the air. So this is the reaction. So both are equal in magnitude, but which are in opposite direction. Because of that, coming the air outside from the nozzle, the balloon will be moving air. It is nothing but what we call balloon rocket. Okay, children, these are the examples of Newton's third law of motion. Thank you, children.
The only question you need to ask yourself while studying the third law is, what happens when two objects interact with each other? What happens when you place an object on the table? The object exerts a force on the table and the subject exerts an upward force on the object. There are two forces that result from this interaction: a force on the table and a force on the object. The magnitudes of the two forces are the same, but the directions are opposite. These forces are called as action and reaction forces. The force exerted by the object on the table was an action force, and the force exerted by the table on the object is the reaction force. What we saw here is nothing but a display of the Newton's third law of motion. Every action has an equal and opposite reaction. That's how simple the third law is. Every action has an equal and opposite reaction. It means that when two objects interact, there is a force on each object. The magnitude of force on the first object equals the magnitude of force on the second one. And what about the direction? The direction of force on the first object is opposite to the direction of force on the second one. Let's talk about more examples. While a frog is swimming, it pushes the water back and the water pushes its body forward. Now let me ask you a question. Say a bird is flying upwards. Will the Newton's third law apply here? Sometimes the third law is not so obvious. You'd probably say that the bird is the only object here and there's no second object. But that's not correct. The wings of the bird push the air downwards and the air pushes the bird upwards. Action and reaction forces make it possible for birds to fly. We take one last example to understand something very interesting about the third law. What happens when a gun is fired? You're right, it exerts a forward force on the bullet. And the bullet exerts an equal and opposite reaction force on the gun. And this exists in recoil of the gun. A perfect example of Newton's third law. But hold on. If the force exerted by the gun on the bullet is the same as the force exerted by the bullet on the gun, then why doesn't the gun recoil with the same acceleration as the bullet? The gun recoils, yes, But it doesn't recoil at the same acceleration as the bullet, right? Same magnitude of forces, but different accelerations. Why do you think this happens? Okay, so if your concept of the second law of motion was clear, you wouldn't really be surprised with this. The second law of motion says that the force is the product of the object's mass and acceleration. Or the acceleration of the object is equal to the force over its mass. What does this tell us? Yes, if the mass is more, then the acceleration will be less. In this example, the mass of the gun is much more than that of the bullet. Hence, the acceleration of the rifle is lesser than that of the bullet. If you're in a boat and step out of it onto the land, there are two forces involved. You pushing the boat behind and the boat pushing you forward. And that's why you see the boat go behind when you go forward. Now let's say a sailor jumps off a huge ship. The sailor does apply a force on the ship and the ship also applies a force on the sailor. But do you think the ship will accelerate as much as the sailor? Not really. And I think you know why.